Assalamu alaikum wa rahmatullahi wa barakatuh. You may remember last year that we have introduced gas strategy, and gas strategy focusing on improving our HSS performance, our reliability performance, our efficiency. And in order to do that, there's many items that we require to work on, whether it is in the technical side or in the people development and TRB improvement, as well as improving our practices. And one of our focus area to improve the practice was the operation area. So in order to do that, we introduced the GOE program. GOE is standing for Gas Operational Excellence, which meant to improve our operational excellence and drive the improvement in reliability and process safety of our operations to the international benchmark. The success of the GOE program will depend on how effectively we engage with it and take our part in executing the piece that relate to us, and also how serious we are learning and implementing the techniques and mechanisms this program brings to us. If we succeed all together in this program and other programs, as I mentioned earlier, on the reliability and efficiency programs, we would assure that gas is going to be a world-class operating site, which we all aspire to be. At the end, I would appreciate every one of you taking the time, learning more about the GOE for better implementation and effective engagement with this program. Wassalamu alaikum wa rahmatullahi wa barakatuh.
As best practice, standard operating procedures should be available for startup, shutdown and normal operation. Team was formed of experienced shift supervisor and DCS operators for updating the existing SOP, as per new SHEM standard. SOP was prepared in phase-wise and all the SOPs were commented and reviewed by process engineers. After reviewed by process engineer, SOPs were uploaded in QPulse in Level 3 documents for utilization as per plant requirement. Awareness sessions with questionnaire were arranged for all the shift team members to get familiarized with the new SOP format.
Bismillah ar-Rahman ar-Rahim. Gas Operation Excellence program is one of the strategic programs in gas developed with 10 processes and divided to 4 phases. The first phase for the communication and awarenesses. And under this phase we have 4 processes related to the shift handover, shift orientation, shift meeting, plus the shift reporting. This is system, or this phase is very important to have proper handover between the previous shift and the next shift.
The objective of shift handover is to provide the incoming shift sufficient understanding of what activities occurred during the previous shift, the present status of plant and what activities need to be done during their shift by the outgoing shift members. This effective communication during the handover shall prepare the incoming shift to maintain the plant status and safety. The shift manager and shift supervisor highlight the plant status and any expected changes from the customers, review daily roster, participate and record what-if drills. Review safety concerns, maintenance activities and review critical parameter deviations and actions taken. DCS operator highlight the plant status and any expected changes from the customers, participate in what-if drills, review safety concerns, review critical parameter deviations and take immediate actions, consulting with shift supervisor, for correction. Outside operator highlight the field plant status and activities undergoing in the plant and expected from maintenance, participate in what-if drills. The objective of shift orientation is to get the incoming shift member to familiarized in his own area, effectively so that they are able to set direction for the required deliverables. This familiarization shall also support during the validation of shift team meeting. Familiarization includes determining the condition of equipment, critical process parameters, trends, status of bypassed protective equipments and plant status. Shift manager and shift supervisor after taking handover review the previous shift reports and notes any changes in plant status, safety issues, critical parameter deviations and maintenance activities. DCS operator reviews the DCS graphics and trends and start noting the critical parameter list and identifies any deviation for corrective action. Outside operator takes a quick round in his plant area and observes for any unusual occurrence like sound, or icing, or unsafe maintenance activity and report back for shift meeting. The objective of shift team meeting and planning is to plan for the next 8 hours for the activities to be conducted by the shift team members. All the shift team members participates in the meeting after quick orientation to validate any activities of their area. The shift supervisor reviews with the whole shift team, safety toolbox, plant status and expected changes in customer demands. Discuss any activities to be conducted by the shift members, and deviation in any critical parameters. All shift team members clarifies any support or activities required within the shift meeting. Roles are assigned to concerned shift team members for monitoring and providing maintenance activities. The objective of shift reporting is to record and transfer information between and within different parts of organization. This includes shift-to-shift transfer, shift-to-managers communication and their feedback. Proper reporting contributes to preventing accidents and mistakes. The shift reporting supports the cooperation between operators, shifts and managers. The shift reporting is done in an electronic logbook, for keeping track of all occurrences and remarks during the shift. Besides the normal operation activities, there are often special activities, like repairs, maintenance or inspections. By keeping a close eye on these activities, like bypasses and lockout tagouts, safety is improved. Shift manager completes the shift manager report and forward to all concerned by email. DCS operator fills the shift handover report highlighting any deviation in critical parameters with corrective actions and activities carried out in the shift, which is reviewed by shift supervisor and shift manager. Shift supervisor completes the shift handover report after reviewing the activities filled by DCS operator, and provides his own comments and forward to all concerned by email.
Phase number 2 is contain of 3 processes related to the alarm management system and related to the critical parameter and validation target. In this phase we are looking to reduce the alarm to the DCS operator and to have more focus to the plant. In addition of that, for the critical parameter we are trying our best to operate the plant within the safe limit.
The push for gas operational excellence, GOE, in plants today is also driving the need for alarm management program. Because plants are operating closer to their limits than ever before, with continuously looking for new ways to increase GOE by reducing downtime, increasing productivity, and implanting real-time performance management strategies for their plants. GAS started alarm management program to free the operator from doing tedious or repetitive tasks, giving them more time to focus on the process and make intelligent decisions that affect productivity and plant performance. Alarm Management Committee build the philosophy and start the rationalization for bad actors alarm, which is the process of ensuring that every alarm requires a unique intervention, defining the specific reason and priorities for an alarm, consistent with the alarm philosophy, and generating the supporting documentation such as the basis for the alarm setting. The consequence of deviation, priority and corrective action that can be taken by the operator. The alarm management benefits: improve plant reliability and avoid process safety incidents. Have few alarms clearly prioritized and presented to the operator. Ensure for each configured alarm, action is needed. Alarms aid the operator during an upset. The system is monitored so performance is maintained. A process parameter whose deviation has an impact on a critical quality attribute, a process safety concern, sustainability issue, or reliability concern, and therefore should be monitored or controlled to ensure the process produces the desired product. A team of experienced shift engineers and shift managers was formed to develop the database for all the parameter in each plant from Operation Insight. The total number of parameters in Jubail are around 21,000, and in Yanbu 9,000. The team then reviewed the criticality of each parameter and rationalized based on process safety, product quality, sustainability concern and reliability issue and developed critical parameter list. The list was also reviewed based on SIL and EHSSC critical list. Critical parameter list was developed for each phase and the total critical parameters are 12% of the total parameters with whom trips are associated. This critical parameter list was reviewed and approved by process engineers. Field reading parameter list was developed by the team for the outside operator to ensure the operator takes a complete round of the plant to identify any abnormality and report to DCS operator for corrective action. Shortly, the manual reading taken by operator shall be replaced by electronic log recorder, which is being done through operator round atomization, ORA project. A team of experienced shift engineer and shift managers then reviewed the operating range for each of the approved critical parameter list. The validation process considered the documents and operating ranges provided in licenses alarm, and trip summary list (PHA), reports and critical parameters consequences. The operating range was verified with the past historical data collected from DCS to ensure the operability within this range. This critical parameter operating range was reviewed and approved by process engineers.
Phase 3, proactive monitoring from operations department and from the technical support. In this stage or in this phase, we are monitoring all the parameters and keeping them within the operating range.
The objective of proactive monitoring is to identify the process deviation and taking necessary actions to get the process back into safe operating limit. This ensures that there is enhanced process safety, improved reliability, productivity and sustainability. Field operator periodically takes field round and log in outside log sheet. Look, observe and report to the DCS operator for proactive action to correct any deviation in the field reading and for any abnormality in the field. DCS operator log in periodically critical parameter reading, and scanning over all DCS graphics, and trends to ensure all process parameters are within the operating range. DCS operator shall take immediate actions to bring back any critical parameter which is not in operating range, and report in the shift handover log. Shift supervisor supports DCS and field operator for troubleshooting any deviation in the critical parameters operating range, and calls the maintenance and reliability team if required. Shift supervisor raises technical service request TSR. If further study needed from process engineer. On daily basis, the process engineer reviews the plant unit's operational parameters and plant's main KPIs. Any observation is recorded by process engineer and cascaded with clear recommendation to operation department through daily KPI report, which is generated daily by noontime for immediate action.
Phase 4, managing the abnormal situation. In this stage, we already developed what-if scenario in Jubail and Yanbu, and during the shift itself, we are doing the drills for that scenario to make sure we are prepared for any emergency situation.
The objective is to manage abnormal conditions arising during startup, shutdown and normal operation. Abnormal situations encompass a range of events outside their normal plant operating modes, for example trips, fires, explosions or just not reaching planned targets. It is a comprehensive process for improving performance which addresses the entire plant population. It promotes effective utilization of all available resources, that is hardware, software, and people, to achieve safe and efficient operations. A team was formed to identify what-if scenarios with its consequences and corrective actions. Schedule was developed to conduct What-if drills regularly by all the shift team members as per shift team plan to be prepared and able to manage during real emergency situations. After successful completion of what-if drill, an evaluation form is filled and highlighting any shortfalls which are